Today we are learning about ionic and covalent substances, and Michael, we learned something, a difference about ionic and covalent substances. What did we learn?
Ionic substances conduct electricity and covalent substances don't.
Very good, excellent. So we've set up a simple circuit here. You can see we have our battery, our bulb, and we're just going to connect the circuit here by connecting these two electrodes. And we can see that when we have a complete circuit and electricity is flowing, that when our current is flowing, the bulb will light. So we've got 4 different solutions here that we're going to test. The first one is pure water. Our second one is salty water. We then have water with sugar dissolved in it, just table sugar. And then our last one is water with copper sulfate, which we would have used last year to make crystals, dissolved in it. Okay, so we're going to test these 4 solutions to see if they are ionic or if they are covalent. Okay, depending on whether they will conduct electricity or not. So the first one we're going to test is water. Now, if I get the 2 electrodes here to sit so that they're not touching off each other. And Jack, from the result there, what can you observe?
Water is covalent.
Very good, so water is covalent. And how can you tell that from the result?
The water isn't conducting electricity.
Okay.
Completing the circuit.
Yes, exactly. It's not completing the circuit and the bulb is not lighting. Very good, so water is covalent. It doesn't conduct electricity. So we're going to test our next liquid here, which is salty water. So it's just water with regular table salt dissolved in it. And Claire, what does this result tell us about salt?
Ionic.
Very good, excellent. And how can you tell from the setup here that salt is ionic?
Because it's conducting electricity to the light bulb.
Very good, so the bulb is lighting and the salt is completing the circuit, so electricity is flowing here. Very good, so salt is ionic, excellent. So we'll move it on now and we'll test our third liquid, which is sugar. Okay, Bridget, now from our result here, what can you say about sugar?
It's covalent.
Very good, so it's covalent, and how can you tell from the result that it's covalent?
The light bulb is yellow.
Good, excellent, yes, the light bulb didn't light, so it means that the table sugar that we have here is covalent. Great, so we'll test our 4th liquid now, and this solution is water with copper sulfate dissolved in it. And Sarah, what happened here?
It's ionic.
Good girl, it's ionic, very good. And how can you tell that it's ionic?
It produces electricity.
Good, excellent. Very good, excellent, yeah. The bulb lit and that meant that the electricity was conducted. Excellent. So our 2 ionic solutions were the salt, the table salt, which is sodium chloride, and copper sulfate, which is CuSO4. There are 2 ionic compounds. In both of those cases, in NaCl, which is your table salt, the hydrogen in an acid, which was HCl, was replaced by the metal Na, sodium. So a metal replaced the hydrogen in the acid. In copper sulfate, in the case of the copper sulfate, the hydrogen in the acid, sulfuric acid, H2SO4, was replaced by copper. So the metal copper replaced the hydrogen in the acid to form CuSO4. That's how salts form, and salts are ionic, so they had metal ions present, and the ions conduct electricity. Water, H2O, and sugar, in this case here, if it's glucose, is C6H12O6. They're covalent, so there are no ions to carry the electricity. Electrons are shared. Okay, so just to summarise, if a solution is ionic, it will conduct electricity, the bulb will light. Whereas if it's covalent, the bulb will not light and there is no electricity carried. Okay.